Every single time you open a browser, shoot off an email, or watch a video, there's this invisible engine working like crazy in the background. It's the absolute backbone of the internet, something you use 100 times a day but probably never even think about. Well, today we're pulling back the curtain and demystifying that system, DNS, the Domain Name System.
So let's get right into it. Think about that moment. You type a web address, you hit enter, and boom, the site appears. But what actually happens in that split second? Because it's not magic, it's an incredible, lightning-fast journey that zips across the entire globe. And we're going to follow that journey step by amazing step.
See, the whole thing boils down to a simple translation problem. We humans, we think in names, right? We remember things like example.com. But computers, they couldn't care less about names. They speak a totally different language, the language of numbers, specifically IP addresses. Every single device connected to the internet has one. And DNS? DNS is the universal translator that makes it all work. Okay, so the best way to wrap your head around DNS is to think of it like a massive global phone book for the internet. Seriously, you give it a name you can remember, and it instantly looks up the right number, the IP address, that your computer needs to actually make the call. Just imagine if you had to memorize a long string of numbers for every website you wanted to visit. No way, right? That's the chaos DNS saves us from. So how does this lookup actually work? It's not like there's just one giant computer somewhere with a huge list. Oh no, it's way cooler than that. It's more like a super sophisticated, high-speed relay race. So let's follow a single request from the moment it leaves your computer to the moment the answer comes flying back. All right, check this out. It all kicks off when your computer asks its local DNS helper, called a recursive resolver, hey, where do I find this website? Now, if that resolver doesn't already know, it does all the work for you. First, it goes and asks one of the big bosses, a root server, for directions. The root server says, I don't know the exact address, but go talk to the .com server. That's the TLD server. Then, the TLD server points our resolver to the final stop, the authoritative name server for that specific website. And that server, finally, has the answer. It hands over the IP address, which travels all the way back to your computer. And the craziest part, this entire global trip happens in milliseconds. It's just mind-blowing. And that whole process, where one server does all the legwork and chasing for you, that has a name. It's called recursion. It's what makes the system so incredibly efficient. Your computer just has to ask one simple question, and this recursive resolver tirelessly hunts down the answer, no matter where in the world it is. So where does all this information actually live? Well, it's not just a jumbled mess. It's all neatly organized into what we call DNS zones. If we stick with our phone book analogy, a DNS zone is like a single chapter dedicated to just one domain, holding all the different contact info for it. And here's where it gets really interesting. DNS is not a one-trick pony. Inside that chapter or zone file, you've got different types of records for different jobs. The A record is the most common. That's the one that points a name to an IP address. But then you've got something like an MX record, which has nothing to do with websites. It tells the internet where to send your email. And a CNAME is just a simple nickname. It just goes to show you, DNS is like the main traffic controller for a whole lot of what we do online. Now, can you imagine having to run that whole global relay race for every single click? It would be crazy inefficient. So the system has a brilliant shortcut built right in: caching. You can think of it as the internet's short-term memory. Your computer and all those resolver servers will just hang on to answers they've recently looked up. So how long do they remember it for? That's controlled by a little setting called the time to live, or TTL. It's basically an expiration date measured in seconds. The person who owns the domain sets it, and it tells every server, hey, you can use this answer for, say, an hour. But after that, you need to ask me again just to be sure nothing's changed. It's this constant dance between being fast and being accurate. Here's something else you might not know. Not all DNS is the same. Most of us just use whatever our internet provider gives us. But you can choose to use a public DNS service, like the ones from Google or Cloudflare, which can sometimes be faster or offer better security. And then, on the flip side, you have private DNS. This is what big companies use inside their own networks to name things like printers or internal servers, stuff that you'd never find on the public web. And DNS isn't a one-size-fits-all deal either. In the corporate world, especially with Windows, DNS is the absolute lifeblood of something called Active Directory. I mean, without it, you literally couldn't even log into your computer. But in the Linux world, the go-to has always been a super flexible open-source program called Bind. Now, because DNS is so critical, it's a huge target for cyber attacks, which has led to important security upgrades like DNSSEC. And the whole global show is coordinated by a nonprofit called ICANN, making sure it all runs smoothly for everyone. When you step back and look at it, DNS is really the invisible, unsung hero of our digital world. It's this incredibly fast, resilient, and decentralized system that's just always there, working away in the background. So the next time your favorite site loads in a flash, just take a second and remember that amazing global race that just happened, all to get you connected. And I'll leave you with this thought. The system was designed in a much simpler, more trusting era of the internet. So the big question for all of us now is, as the threats get more sophisticated, how do we protect this vital, foundational directory that we all depend on? Thanks for watching, and stay curious.